Let's look at this situation, which we have seen in our earlier videos. Two beakers are connected with a pipe. One of the beaker is placed at height above the first beaker and the water will flow from one beaker to another beaker. If you understand this example, you will understand the Ohm's law. Just focus for 2 minutes and you will master the Ohm law. As we have discussed earlier, it is the height difference that makes the water flow from higher beaker to a lower beaker. But what if I increase the height difference? Yes, the water will flow much faster. So we can say that the flow of water is directly proportional to the height difference. Now look at another factor. How thin is the pipe? What happens when I make the pipe thinner? The flow of water will be slower, right? That's correct. Thinner the pipe, slower the flow. So we can say that the flow is inversely proportional to the thinness. Looking at these two relations, we can say that F is equals to H over T. The flow is directly proportional to the height difference and inversely proportional to the thinness. Why I gave you this example? Because it is analogous to Ohm's law. The flow of water is analogous to current, the height difference is analogous to potential difference, and the thinness is analogous to resistance. The current is directly proportional to the potential difference and inversely proportional to the resistance. More the potential difference, more will be the current. More the resistance, lesser the current. This is assuming that other factors are constant. The Ohm's law gives us the relation between current, voltage and resistance. It tells us that the electric current is directly proportional to the potential difference and inversely proportional to the resistance. Let's do a quick activity to know more about Ohm's law. We would need a nichrome wire, voltmeter, ammeter, and 3 electric cells of very low voltage with a range of 1 to 1.5 volts. First, we will form a circuit which has only one cell as its source. This is a nichrome wire which is acting as a resistance. This is ammeter in series and this is voltmeter connected in parallel, and this is a plug key. You will close the plug key and note down some readings. We have to note down some readings from ammeter and voltmeter. Let the current and potential difference be I1 and V1. In the second case, connect the two cells in the circuit and note the respective readings of the ammeter and voltmeter. Don't forget, ammeter measures the current and voltmeter gives the potential across the nichrome wire. Let's take two readings of I2 and V2 respectively, and then repeat the same procedure for the third cell. You will notice that as the number of cells increases, the current and potential difference will also increase. But are they increasing proportionally? To know that, we have added an additional column which calculates V over I for each case. The ratio in all the cases are equal, which shows potential difference is directly proportional to the current. The relationship was discovered by the scientist George Simmons Ohm in 1827. Notice the resistance there is constant and the temperature is also constant. This is the Ohm's law. If V is directly proportional to I, it also means V over I is constant, and this constant is nothing but the resistance. What is resistance? It is simply the property of a conductor to resist the flow of charges through it. Unit for voltage is volt and the unit for current is ampere. But what is the SI unit for resistance? It is ohm, which is represented by the Greek letter omega. If the potential difference across the two ends of the conductor is 1 volt and the current through it is 1 ampere, The resistance of the conductor will be 1 ohm.